Hello and welcome. Here is the next tutorial from our series about sculpted prints with Blender. This time we will take a closer look into texturing. Our main goal will be to let the top hat look much more glamorous. So far, we have created a very basic material for our hat. We have baked the texture and got an almost completely black image with a red area for the hat band. We will proceed from here by introducing a few new texturing techniques. In particular, we add ambient occlusion to the object. We will take a brief look into the Blender light system, and eventually we will add light-dependent shadows and colored light effects. We will see how we can add a shiny effect into the textures. And at the end we will see how we can improve the look and feel even more by creating and adding bump maps to our textures. Ambient occlusion describes the illumination of your scene with only ambient light. Ambient light has no recognizable light source. So if you're sitting in a space which is illuminated only by ambient light, then the amount of light energy getting to your eyes is not dependent of the angle of incidence. The only variation on light intensity can be introduced by occlusion, either from other objects or by self-occlusion. With decreasing aperture angle, the edge between two faces gets less and less ambient light, hence it renders darker and darker. So the ambient occlusion value for each point on the object surface is calculated by moving to this point and calculate how much of the space around the point will get occluded either by the object itself or by other surrounding objects. The ambient occlusion value for each point on the object surface is the fraction between the occluded space and the non-occluded space. Consequently, when a point is fully occluded, the pixel value gets black. When it is not at all occluded, then it gets white. As an example, a flat surface will be rendered gray because the object self-occludes half of the viewing sphere. Although ambient occlusion is an artificial calculation, it helps us to make an object look more realistic, and since it is not depending on the camera position, it can safely be baked into a texture. Now let us see how we can use ambient occlusion on our hat. Unfortunately, the hat is totally black at the moment, and thus the whole effect of ambient occlusion will be mostly invisible. So let us change the hat color to white for now, and switch back to black later. Select the hat body and go to Edit mode. Ensure that you are in the Edit button section. Select the black material using the Material Index selector. Click on the black color area and change the color to white. The hat will become gray. In the following sequence we will add some slight modifications on the model to optimize the texture baking. It is always a good idea to keep your model as it is, and work on a copy of it. So let us go back to Object mode and select the hat, then Shift select the tie and the bow. Now copy the selection by pressing Shift D, and immediately click the left mouse button. Now we have two separate objects precisely intersecting each other. We will move one of the objects to another layer, and keep this copy as our reference model. Press the M key. A small layer selector box opens. Choose layer 6. Now you have one copy of your object on layer 6 and another copy on layer 1. Go to layer 1, and select the object there. Ensure that you also have selected the UV text map, which was introduced in the previous tutorial. We will use this map for the preceding work. Go to Edit mode and select all vertices of the hat. In the UV image editor, create a new image. Be gracious, and make this image large. For our purpose, a size of 1024 pixels in each dimension is sufficient. However, you may want to use an even higher value when your object has got many fine details. Rename your image to AO Map. Switch to the Shading tab, and there select the World buttons. Locate the Ambient Occlusion button, and enable it. Keep everything to the defaults, and just bake the Ambient Occlusion map by navigating to Render, Bake Render Meshes, Ambient Occlusion. It may take a few seconds to generate the map. Let us take a closer look at the map. If you see black triangles, this is most probably because we have introduced a pole at the top of the hat. We will correct this in a moment. If you look close to the map, you see that the neighbor objects do have an influence on the amount of darkness. This is so, because the ambient light gets occluded by nearby objects, here in particular by the bow and the tie. You also can clearly see the border of the brim. But the whole image looks a bit grainy. For a good ambient occlusion map, we will want to correct this too. So let us first take care of the triangles. Go to Edit Mode, switch to the Edit button section. Locate the pole, and select its vertices. You can look at the top menu bar to see how many vertices, edges, and faces you currently have selected. There should be 8 vertices in the current selection. Then switch to the Edit buttons, and click the Smooth button once. You have now introduced a hole at the top of the hat, but don't care about that, we will close it again later. Now go back to the Shading section. And within the World buttons, locate the Ambient Occlusion tab again. Change the number of samples to 20. This number will determine the degree of smoothness of your map, but it will also make the map calculation take much longer. Don't fear, you only need to do this once, at least as long as you do not change your model anymore. Now bake Ambient Occlusion again. Go for a cup of coffee in the meantime. Later you might decide to make the map even bigger or use even more samples. For now, our occlusion map is good enough. It is a good idea to store your image on disk now, otherwise you will have to recreate the map later, and you probably do not want to do that often, because it is a time-consuming task. Well, now we have baked the ambient occlusion into an AO map. We can take this map, reduce it to a reasonable size of, let us say 512 by 512, and use the result as texture for our hat and Second Life. Then we can use the Second Life color picker to colorize the hat, and we are done. But what if we wanted back the red color band? It is not included in the AO map. So let us see how we can bake the texture in the AO map all together. Go to Edit Mode, and select all vertices. Now change to your hat texture. You possibly may want to create a new image here, with a reasonable size. 512 by 512 pixels should be okay. And finally bake the texture only. Okay, we somehow expected this to happen. When enabling Draw Type Textured, a totally white hat with a red band is what we get. See how different the model looks now? All three-dimensional information is almost gone. Switch forward and backward between the AO map and the texture. See how nicely the model's three-dimensional characteristics get supported with the ambient occlusion map. Now wouldn't it be nice to have both in the texture, the color, and the ambient occlusion? Here is the trick. Check that you are in edit mode, and all vertices are selected. Also check that you have the hat body texture selected in the image editor. Then go to the shading section. Select the material buttons. Now locate the texture stack, and add a new texture to it. Name it AO Texture. Go to the Texture buttons and select the texture type, Image. From the upcoming selector box, select the AO map. By now we have added the AO map to the texture stack, and it is again time to render, bake render meshes, texture only. So this is not what we expected. What is missing here? The ambient occlusion was generated by using the Sculpted's UV map. This was automatically and silently done when we baked the AO map. And this was a good decision because you just can use the AO map on your Sculpted without modifications. But now we apply this texture as an image. So Blender needs to know how to wrap it correctly around your model. And this is done as follows. Go to the Material buttons. Select the AO texture if it is not yet selected. Switch to the Map Input tab. Enable the UV button and specify which UV map shall be used for baking. Of course, it is the same map which we implicitly used before when we baked the AO map, namely UV Tex. Now bake texture only again. And the result is your base material texture plus the ambient occlusion map, both smoothly merged. But wait, we are not yet done. The red color band does not show any ambient occlusion yet. Why is this so? Well, until now you have only applied the AO map to your black material. And the hat band material does not see it yet. So let us correct this now. Go to the Edit section. Now select the hat band material by using the Material Index selector. Go to the Material buttons. From the Texture selection box, select the already existing AO texture. By doing this, the previously created ambient occlusion texture gets reused for the hat band. But we still need to switch to the Map Input tab. Enable the UV button, and tell Blender again to use the UV text map. And finally do another render, bake render meshes, texture only. And the frustration is big. The hat band is gone again. Why that? Well, we had fallen into a trap. Something slipped through our attention. Let us go back to the shading buttons, and check the Map 2 section of the material. We see that the blend type is set to Mix. So what gets mixed here? Everything on the stack above the current texture will be mixed with the current texture. But since there is nothing above the current texture in the stack, the base material settings are taken instead. The amount of mixing is defined by the value of the color variable. Currently this value is set to 1, and thus the current texture on the stack completely replaces what was there before. So neither the hat band nor the white hat body is rendered, and only the AO map is seen at the moment. We have several options to proceed from here. The simple solution is to change the mix value to 0.5, which would do what the name implies. It mixes the base material and the ambient occlusion map, both with an amount of 50%. But this option creates washed out textures. An enhancement could be to use blend mode overlay for the hat band, and set the color value to 1. This will result in a much crisper color definition, and still contain the ambient occlusion. Another, and probably the best option, would be to use the ambient occlusion map as multiplier on the hat band. So it does only affect the light intensity of the texture. You will need to play with the color value, until you get a convenient result. Finally, let us make the material black again. Go to the Edit button section. Switch to the hat base material. And make the hat base black. In the Map 2 setting of the hat body, set the color value to 0.5. This will eventually result in a dark gray hat with still visible ambient occlusion. So far, we have created a texture which contains our basic material settings, namely the black hat body and the hat band. We have added ambient occlusion by just using the AO map of the texture on the texture stack. And now we want to add some extra lights, and bake those lights into the texture. So let us first check what we can see right now with Blender's default light setting. Do this by clicking on Render, Bake Render Meshes, Full Render. Okay, this is disappointing. We obviously will have to add some lights. Please note that normally we will set up light in such a way that all objects look nice from the camera location. You would not necessarily take care about parts of your object which point away from the camera. But for baking textures, this is no longer exactly true. You will want the object to be illuminated in a different way. Here is one possible way to go. We will use 4 lights in total. While proceeding, we want to get a rough idea about how the lighting will influence our texture. We can use the draw type, Shaded, here. This mode simulates the light effects in real time. But take care here. If your computer is not fast, or if your model contains many faces, or you got many lights in your scene, shading mode can start to consume lots of your computer resources. So if your Blender is freezing, you have to reduce either of the before mentioned settings. With your draw type set to shaded, go to the shading section. There, switch to the lamp buttons. Go to top view. This will help you to find good locations. Finally, add a new Hamey light by clicking on Add Lamp Hamey. Place this light besides the camera, and slightly above the hat, and rotate it so that it points towards the hat. You will switch the viewpoint between top, front, and side view for this adjustment. Now reduce the dist value such that the pink line is as long as the distance between the lamp and the model. Go to top view, and add 2 more Hamey lights at an angle of plus 120 degrees, and minus 120 degrees, both relative to the first lamp. Here is a quick way to get this done. Place the 3D cursor on top of the hat. Set the 3D cursor as pivot. Select the Hamey light and make a copy of it by pressing Shift-D, immediately followed by a left mouse click. Press the Alt key, and enter 120 on the keyboard. Make yet another copy of the just created light, and rotate it again by 120 degrees. Finally, add a 4th light, which will illuminate the hat straight from the top. Now set draw type to texture to see what you will bake. Then select the hat and start another full bake to see what changed. Okay, still not too much of enhancements. The model still looks very artificial. What really is missing here is an interesting structure of the material, and we can do a lot with texturing here. But before we do this, let us first add a bit of shininess and contour to the hat. Go back to draw type solid. You now see some specular reflections on the hat. These reflections are fully dependent on the camera viewpoint. On the other hand, we can only add static information to the texture, which is independent of the camera viewpoint. But we can use a trick here. We will create a node-based material and use the specularity information to modify the texture. But beware, the trick may not always create the expected results. You will need to do some experiments to figure out how you must set the light to get the reflections where you want them to be. If used carefully, this trick can add interesting effects to your final result. But at the end, always remember that this is a fake reflection which probably interferes with the second light rendering engine. Anyways, let us try this out now. If you don't get it at the first time, then try it again and again. It is by far simpler as it appears to be. So here we go. Ensure that you have selected the black hat body material. Go to the shading section. Locate the link in pipeline tag, and there, enable nodes. Now this material is node-based and you can modify it by using the node editor. So let us split the screen and open the node editor. You see two boxes. The left box is the material node. The other box is an output monitor, which displays the resulting material. Now we will replace the material node by an extended material. We do that because the simple material does not have a specularity channel while the enhanced material has got one. So remove the material node by first selecting it, and then press X, or the delete key. And add an extended material from the Add Input section. Now add a mixer by pressing the space bar, then add Color Mix. We need the mixer to mix specularity information and color information. You see that the mixer node has already been connected to the material node. We will change the connection slightly by moving the diffuse connector to the specularity connector. Actually, we simply click on the specularity connection, then drag to the second color input of the mixer node. Then release the mouse. The connection has now been changed. We connect the mixer to the out node by clicking on the color output of the mixer. Then drag the mouse to the color input of the out node. And finally release the mouse. Now the nodes have been set up, but the material node still must be connected to an existing material. Go to the material node and there select the black material from the selection box. Now the node-based material is ready to go. Finally bake render meshes, full bake again and see your results. Ensure that you are in draw type texture to see the results of your bake. Now we get somewhere. There is still much room for improvement, but now the look of the hat has become much more interesting. So with applying specularity, the hat gets much more contour. Let's do yet another enhancement. Look at the top edge of the hat body. There you see a specular effect, but it is not very well defined. The reason is that the model is using the low poly mesh, but the texture should be created with a much finer mesh and then baked to the low poly mesh. We will come to this technique later. For now we can just increase the number of subsurf levels by 1 or 2, and then full bake again. Go to the Edit section. Locate the modifier stack. Increase the number of render levels by 2. And now bake. This will already give you a significant improvement. After baking, all the fine details are visible in the texture, and so you can get very fine details without increasing the mesh face count by just baking them into the texture, and using this texture on your low poly model. Now play around with the lights and see how your specular effect changes with the light settings. For example, you could get a bit adventurous and colorize your lights. Check that you are in draw type shaded to monitor your changes in real time. Also take care that the sum of all lights mixes more or less to white. As an example, use one light with red, the second with green and the third with blue. and effectively paint on your hat with your light sources. Check the results by going to Draw Type Textured, and start another full bake. And now it is time to examine the texture stack, and add more structure to your surface. A realistic top hat will be made out of felt, or a comparable material. So let us try to get such a texture for our hat now. We will try a procedural texture here. Select the black material in the Edit button section. Then go to the Shading button section. And there switch to the texture stack, create a new texture, and name it Felt. Switch to the texture buttons, and select texture type, Voronoi. Now make a full bake to see what happens. Okay, this is yet another surprise. Now, why is this hat pink? For some reason the developers of Blender have chosen to use pink as the default color for any texture. We will change this in a moment, but let us remember what we wanted to achieve in first place. The hat should look like made out of felt. So also the size of the dark spots seems wrong, and we want to get a much finer result. Now let's go. Locate the noise size setting in the texture button section. Change the value to 0.02 or any other value to your taste. Switch to the material button section. In the Matte 2 tag, change the secondary color from pink to white. Then bake again. The spot size is still much too big. So let us change that in the map input section. Change the size settings from 1 to 40 in all dimensions. Then bake again. Now the hat is almost like we want it, but it has become light gray. This was because we have chosen the secondary texture color to white. We could have used gray instead, and thus keep the hat darker, but we will do another much better trick. Go to the Matte 2 section. There disable color and enable NOR. This means that texture no longer changes the color of your model, but now affects the normals. The amount of the effect can be set with the NOR value, which we will set to around 1.5. Now bake again and see. Okay, try to reduce the specularity. Felt is not shiny. And bake again. So, by using a noise texture as normal map, we created a material resembling felt. We still can find improvements, and there may even be much better approaches. If you know an interesting approach, feel free to tell it to us. Now let us turn back to the red color paint. It still looks like it was painted on the hat. We will now try to let it appear as if it has been wrapped around the hat. Of course, we could model this detail easily into the mesh itself. But I will demonstrate instead how we can add higher resolution details to a low poly mesh by using the bump map. But before we get practical, I will give you a brief idea about what is going on behind the curtain. Please remember that this hat has been created with 8 faces in X and 8 faces in Y. Hence in Blender it is made out of only 64 faces. But in Second Life, we count 32 times 32 faces, hence we see 1024 faces there. All these extra faces have been calculated by means of a subcirc modifier. Then they have been converted into the final sculpting mat during the sculpting baking process. In order to see what happens, we will tell Blender now to show us these extra faces right on the model. But instead of using the original model, we will create yet another copy and work on the copy instead. Go to Object Mode. Ensure that the hat is selected. Also select the lights. We will need them in a few seconds. Then press Shift-D, and immediately click the left mouse button. Press the M key, and move the copy to layer 5. Now we have copied our model plus our light setup to layer 5. Switch to layer 5, and select the hat body. Go to the Edit button section, and locate the modifier stack. You will find one subcirc modifier there. Ensure that the number of levels is set to 2. Then click the modifier's Apply button. And finally switch to Edit mode. What you see now is almost identical to what will later be imported to Second Life. The model is now made out of 32 x 32 faces, so there is not much more room for finer detailed modeling. But let us make an experiment. Let us add another subcirc modifier, and add 3 more levels of subdivision, and then apply the modifier. Now we do have a very high poly model, which contains more than 64,000 faces. Indeed, I have chosen the numbers such that we could use a texture of size 256 x 256, and end up with exactly 1 image pixel per model face. Now let us apply a bit of noise to the high poly model. We enable that proportional edit tool, and select the random fall off. Then we select just one vertex, and scale up or down, while we increase the edit range more and more. Once the hat looks like a hedgehog, we stop and full bake what we have right now. Now the texture contains the light effects of the noisy surface. Now switch to layer 1, and see how the same texture looks on the low poly hat. So the low poly hat looks similar to the high poly model, at least up to a certain extent. You see that you can at least in principle use the texture to add some fine details to your object without actually adding more vertices and faces to your mesh. But we also can turn the whole process head over heels. Instead of using the high poly model as our source, and bake the results to a texture, we also could use a special, typically a black and white texture, where the color value of each pixel of the texture defines a certain displacement of the surface, along the face normal of the corresponding location. Blender introduces bump maps, normal maps, and displacement maps. Bump maps can be used to simulate what we just have shown with our high poly model. Blender will create a virtual mesh point for each pixel of the bump map, and raises or lowers this virtual mesh point along its vertex normal, depending on the pixel's color. As a result, a bump map simulates a surface with much richer detail than the actual mesh supports. So bump maps can enhance low poly meshes, and let them appear much more structured, as they actually are. Normal maps are very similar to bump maps, but instead of a grayscale image they use an RGB image for the vertex dispositions. Hence normal maps can be used to move the virtual mesh points in an arbitrary way. So we can say that bump maps are a special case of normal maps, where the modification only takes place along the vertex normals. Displacement maps directly modify the mesh during bake time. And in contradiction to bump maps, this map type cannot add fine details into the texture. The amount of displacement is again directly coupled to the grayscale value of corresponding pixels in the map. Black will displace a vertex inwards along its vertex normal, while white will displace the vertex outwards. So the effect of displacement maps can always also be achieved by directly modeling the mesh itself. Displacement maps are of less concern when dealing with texture baking. But nevertheless, I will show you a nice example where we can use them for our purpose. We already used bump maps when we created the felt surface texture. There we have configured Blender to use a noise texture as a normal map, and by means of this we simulated a high poly surface. So, now we are ready to take care of the hat bend. We will create a texture which is completely white at the locations which correspond to the hat bend, and completely black elsewhere. This map will simulate a small raise of the band above the hat. We create this texture as follows. Remove the high poly hat from layer 5. We do no longer need it. Select the hat on layer 1, make a copy of the hat base, and place this copy on layer 5. Select the hat on layer 5, and go to Edit mode. Switch to the red hat band material. Switch to the shading button section. Create a new material named white hat band, and make it white. Disable the nodes button, and disable all textures on the texture stack. In edit mode, verify that the hat bend vertices are now assigned to the new material. Switch over to the black material. Again, go to the shading button section, create a new material, disable the nodes button, and disable all textures in the texture stack. Now select all vertices, and in the image editor, create a new image of size 1024 x 1024. Name it Bend Bump Map. Then render, bake render meshes, texture only. Now we have constructed the bump map. We only need to apply the map to the hat now. Switch back to object mode, and then select layer 1. Select the hat. Then select the hat band material. And switch to the shading button section. There, add a new texture and name it Bend Bump Map. Go to the texture settings. There, set texture type, image, and load the Bend Bump Map. Now switch to the shade buttons. In the map input tab, enable UV, and specify UV text. In the Map 2 section, disable color, and enable normals. Use a value of about 20 for an hour. Now you can render, bake render meshes, full render. The effect is not very prominent, but it works. However, we can get a bit adventurous, and try to use this map as displacement map. Remember that the baker will first apply the modifier stack before baking. Hence we actually have 32 x 32 faces available for the displacement. So reduce the NOR value to something below 2. And enable that disc button in the Map 2 settings. Set the displacement value to something about 0.15. Then fold bake yet another time. And at the end the hat bend looks like it actually was modeled in 3D. And this is what we wanted to achieve. Let us add some horizontal stripes to the bend. In the edit section, ensure that you have the red hat band material selected. In the shading section, add another texture. Name it Silk. Go to the texture section, set the texture type to Clouds. Go back to the shading section, then in the map input tag, set all values to Y in the coordinate map. Also enable UV and set UV text as the map. Finally set the Y size to 10. This setting will create horizontal stripes. In the Matte 2 section, disable color and enable normals. Use a value at 5 for NOR. Now render meshes, full bake. Mischief accomplished. The final texture of this tutorial is ready for import to Second Life. From here you can take a long time to experiment and improve. I have not shown all available texturing options in Blender, I just scratched the surface. In particular, we have created an ambient occlusion matte for the object. We have taken a brief look into the Blender light system, and we added light-dependent shadows and colored light effects. We found a way to bake a specular reflection effect. And at the end we have improved the look and feel even more by creating and adding bump maps to our textures. You can find hundreds of good texturing tutorials in the internet, and once you have mastered the basics of this tutorial, you should be able to follow those other tutorials without problems. And now enjoy texturing and have fun. See you later.